All right, we're back, and we are COMP123, summer 2016, week 5, part 2 of our broadcast. We just finished doing actually what's called a Fisher-Yates shuffle. Fisher-Yates shuffle, that's the one. So if I ever refer to it, maybe on a test as a Fisher-Yates shuffle, you know what it is. I'm shuffling two values randomly, right? And there's a guy up on Wikipedia, right, that you can look up how it's done. They actually give you the algorithm here as well. This is written in generic C, right? And you can see how this is done. If you actually read through it, it tells you how to do this idea of this in-place shuffle. All right. So this is, we've done the three that we need for the lab, right? Now we need to create our class. I'm kind of doing it the backwards way, right? I've kind of created my methods first, tested them in my program driver class. By the way, sometimes we do it. We test a method in our driver class. If we don't want to use a test case, we can test it exactly like this. And then what we do is we pass it in. We create a class, and we need to modify our methods to work with our class. Because our methods won't work like the same way in our class. They need to work a different way. Let's talk about this. First of all, let's construct our class. We're going to right-click, and we're going to add a new class, right, that we're going to call deck with a capital D. Right? Usually we call our classes capitals, right? Deck. Except this time, deck is going to extend, like we've done this before, a list card. That's what it's going to be. So when we look at deck, I want you to think of it as extending the list class. The built-in list class, we're going to extend the list class, and we're going to call it deck. Now we're back to inheritance again. When I use my colon here, anything after the colon is the superclass, and now my deck is the subclass. Okay? Very important. When I construct my deck, I automatically, it has a is-a relationship. So the deck is a list. Okay? It's not, the deck is not a something else. It's a list. And it's a list of card type right away when I make this. Okay? Just these lines here make this deck a list of cards. If I hover over it, it'll tell you. It kind of comes from the the list card class. Okay, that's good. So I need these. That's one thing I'm going to do. I mean, I certainly could create other objects right now under. I'm going to create a constructor too. But I could avoid using the constructor for a second, because my constructor, what does it do, right? The empty constructor, when I instantiate, think about it this way. If I instantiate my deck, if I make a new deck, it should automatically call the private create class, create method. As soon as I instantiate my deck object, my deck should have all the values inside. I shouldn't have to call it separately. That's just silly, right? So let's do this now. How do I do that? So first, let's do some documentation. We're going to call this the deck class. This class extends the list card object. Generic type. So it does, right? And of course, we're going to use the at class deck. That's what it is, okay? So deck is an extension. It extends the list, and it's of type of card. You can't just say list with nothing inside there, or else it would just be a generic list. Number one. Second thing is, I want to include a constructor, right? It's got to be called deck. So I'm going to do CC, and then make my public constructor. And I also want to make this a public class. I want to use it some other places. Let's make it public. By default, it's private, right? So public class deck, and here's my public constructor. This is my default constructor, right? This is the default constructor for the deck class. Okay, and we're going to say at constructor, call it deck. No, with no parameters. That's called the default constructor, right? And by the way, I like to also do, when I do constructors because I did my constructor first in this particular scenario, I want to do the following. I want to, you know, kind of put a bunch of pluses here, you know, and kind of do something like, just as a separator, and this, call it the constructors. Because maybe I have more than one constructor. Right now I won't. Maybe I'll have more than one in the future of my deck class. Okay, so it doesn't do anything right now. It's just a empty constructor, right? Okay, let's make my other stuff. Well, instead of making all that stuff, let's copy it in. I've got my create deck, right? And I've got my other stuff. Let's copy all this stuff in. So I'm going to copy all this all the way down to, I'm not going to redo I can reinvent the wheel here. I've already got it working. So I'm going to copy all this stuff. Notice I'm copying, not cutting, right? And paste. Now there's some problems here. First of all, notice that it works as is, but I don't want them to be static, right? Static shouldn't be. And if you give it a second, I got to give mine a second. Static means that whenever I have a static keyword in my class, it means I do not have to instantiate an object of that class for me to use the whatever static thing I'm making, right? And also, every other object in that class shares the static method or value, right? Which means they're not individual, they share, right? So public void shuffle deck. And by the way, should my shuffle deck be public? Yes, it should. That makes sense. That's why it's capital S. Let's go back up again. And this isn't it list type. Here's something, list card deck. Do I really need to pass in the card anymore? No, my deck class is the deck that I'm shuffling. This is where we're going to get a little bit hairy. I'll come back to this in a second. Same thing with this one. Here's my display deck. That's a public class, public method, no problem, right? This one, create deck, no. I don't want anyone to create my deck, you know, again. I want them to, whenever I create a new object of deck type, right, I want this to happen automatically. So we're going to call this method, we're going to rename this method underscore create. Maybe another name for this would be initialize. Let's just leave it as create with lowercase. Now that means that this is a private method, and it's not static because it wouldn't be static, it would just be private. And that's one thing that it would be, right? Did I copy the, hold on a second. I thought I copied everything, even the comments, but maybe I didn't. Maybe I didn't. Yeah, I want to copy those comments. I'm not going to copy. I'm not going to, you know, copy those again. So, and private. Sorry, take away the static. Rename the thing to underscore create. Notice I called it create. I'm not going to use create deck. In fact, all these ones should be renamed, right? Instead of display deck, this should be called display, capital this, right? And we're going to change this later on to something else next week. And this one is, instead of shuffle deck, it'll just be called shuffle, right? That makes sense. The shuffle method, right? The display method, the underscore create method. Yeah, create method is interesting. But now I'm passing in deck. I'm going to need to pass in order for me to use the display method and all these methods, I'm passing in deck. Well, guess what? This is a deck. So I could pass in the keyword this, right? Because this is the deck that we're talking about that we're passing in, right? Well, that doesn't make any sense, right? What would I pass in my own class? It has access to this always, right? Because this holds the value to everything that I want to add in, right? Which means I have to make some changes. One, let's start with the create method. I want to get rid of this. So it doesn't take any kind of parameters whatsoever. It already has those parameters available because it's part of the class itself, right? In my create method, I'd still do this temporary stuff, string, temporary variable. And when I come to this where it says deck.add, what am I going to replace deck with? What am I going to replace deck with? The girl in the I Love Life, is that I Love Life shirt? What is it? What am I going to replace the word deck with? Guess. This. The keyword this is what we replace it, right? So you take this and put it this, because this, the keyword this represents the class itself. And since the class is a deck list card type, remember? The class itself, here's my class, it extends the list card, so therefore deck is a card. or list card type, right? So therefore, I don't have to pass it in. It is that. It holds, the actual deck holds the values of everything else, right? I don't have to do that again. That's one. And it's okay to not know, like I said. So this add, if I just use the this.add, in fact, I can even get rid of this altogether because I can use the add method that's built into this class, because this class has the add, remove, all the different methods that are built into the list. My little new deck class has them, because my deck class is a list. It's just a specialized list that I made, right? Of type card. Okay, so that's the first thing. So this I don't need to put that in. And if that's the case, then let's change this up. I don't have a parameter here either, right? If that's the case, my display doesn't need this to be passed into it either, because I already have that information, right? And it says card in deck, card in this is what I want to pass in. That's what a card, the first card in each of the items in my list, right? Just replacing deck with list, this, right? Same thing down here. I don't have to pass this in here, right? And notice that says where it says this deck.count, I'm going to replace deck with this .count. How big is my list that's part of my deck class? This .current card, right? This .current card. This .random card, right? This and then remember I told you how important it is to use this. This is the reason. No pun intended, right? So this represents the class itself, the object itself. I'm saying, hey, take the current card of this object, the deck, right? Which is what I'm creating, and swap. Now this is where people get a little bit lost, if you're not lost already, right? What it means is, when I use the this keyword, I don't have to create a new deck. The class is a list. Once I inherit, I'm inheriting all the methods and objects, methods and properties that I have from the list class that's built into C#. I'm inheriting it. So deck is a list. And that's why I keep saying is-a. It has an is-a relationships, right? So therefore, I can use it as if I already have the add, the count, the remove methods. It already has all these things built in. Okay. Let's just fix up all the commenting, right? So create deck is not create deck, it's create. It's also private, right? So at private. And these are our private methods. So we're going to say private methods, right? Because we only have one private method right now called create. We're going to do it one time. And we're going to have a section down here with public methods, and the first public method is display. Right, so here's our public methods. Right? So I'm just commenting here just to clarify for clarification purposes. And again, we'll change the name in our documentation to display. Right? And again, down here, no parameter. We don't have to pass anything in there because we already have the parameter. And you can see that the shuffle deck is not shuffle deck, it's shuffle. Now we've made a lot of changes. We need to recheck everything in program. We made a lot of changes. There's like 3 things. We made a whole new class and swapped in our methods we made in the program driver class. We've swapped them into our class. What we've done is constructed our class by using 2 things. We use inheritance, and we've used class composition, because we're composing our class based off our card object. Whew. Let's check this out and see if it works. Let's go back to my program class. Obviously, this isn't going to be needed anymore. So let me get rid of, to test, everything other than main. I don't need anything other than main. Let's get rid of all this public static stuff. We don't need it anymore. Whoop. All this stuff gone all the way down here. Okay, notice how this is all failing now because there is no create deck, display deck, shuffle deck methods. We can get rid of all this. And now when we declare a deck of cards, we don't do it this way. How do we do it? Well, we know that there's a deck class. So we can go deck, lowercase deck, right, is equal to a new deck, right? That's our deck of cards. When I do new deck, I want it to initialize all my cards. And that means in my constructor method, which is right up here, I want to call the create method. So this, that underscore create, calling my create method. So this means, create my deck of cards. That's what it's going to do. Right? Let's create my deck of cards. This is what this does. When I call when I create my deck, I automatically create my deck of cards. I already construct it. I already create all the the values for my deck of cards. I do that right away because that's what the create method does. Right? Just like we tested earlier. Okay? And then my two public methods, that's only internal. I can only use those privately inside my class, my create method. But the two external methods are display and shuffle. Those are the two methods that exist outside. Okay. All right, cool. So I've got this. Now I want to do my other things that I did earlier. So I want to say deck dot. That's funny. I want to do display. So I want to display my current deck. Look, I can do it like this now. It's called deck. Instead of me calling the display method, display is part of my deck class, right? And then I can do something like this, deck.shuffle, and deck.display again. So this will take the place of what I did earlier. So here, instead of a list that represents a deck of cards, what I'm really doing is, I'll do it inline this time. And I'll put them together so you can see that the same order is here. And I can say, create a deck of cards. Right? And the next one is my deck display, right? Display the initial state of the deck. Right here, shuffle the deck, right? Again, the words become a little bit more intuitive. There we go. And this is display the deck again. After shuffling. So we should see the difference here. All right, let's test it out. So how do I do that? I control F5, and if everything goes well, then we'll have almost identical to what we had before. And let's take a look. So here's our original cards, 1 of hearts all the way to 13, right? And here's the second one. Oh, we kept the card 52. A friend made us print out the number of cards. We got to get rid of that. That's the defect, right? And then we said 12 of hearts, 2 of clubs, so it shuffles the deck. This is the new way the deck is going to look now after the shuffling. Okay. This is good. Let me just fix that piece. Right? And in our shuffle, we're printing out the card count. We get rid of this piece. And we've added a whole new deck class. So now we have 2 classes. Our card class, which holds the shape of each of our cards, and our deck class, which is derived from or extends the list class, list with a type of card, right? Extends that and actually has 3 methods that we made, right? Like we said before, we have shuffle method, the display method, and we have the create method that's private. All right? Let's do that. Let's put it up to GitHub. So I'm going to go home. I'm going to go changes, and you can see that I've added a deck and I've modified my program. So I'm going to say add that to staging area. I'll say created deck class. And then I'm going to go home, and I'm going to go sync, and I'm going to go push. Questions, questions, questions. Please ask me the questions now. Because if I look at my Solution Explorer now, let's take a look what I have. I have my deck class, and I have my card class. Let's go over this one more time. My card class is a small class that I'm using, and all it has is faces and suits. That's all it has, right? And my public card constructor takes two properties or 2 parameters. One is a face, which is of type int, and the other one's a suit, which is type string. Okay, that's the 2 things that the card class takes. Okay, so I'm going to use this, which I do. I'm going to use this inside my deck class when I construct my deck class, which is in my create method. Here's my create method. I kind of I iterate through, I decide which one which suit I'm gonna go through first, right? And then I iterate through and I use the add method that's built into my list. Like my deck is a list, therefore I can do this. I can go this.add, and now I'm gonna use an anonymous, I'm adding an anonymous card. So add anonymous card object to the list, right? That's what I'm doing. And the card is using both a face, each card needs a face and a suit, and I'm giving it to it, right? The suit is the one I decide up here in my iteration, and the face is the second for loop that I get the face, the value of the card, right? And I'm adding these into the list, which is the actual object itself, when I do the create. That's what I'm doing, an anonymous value. I could also have broken this down to 2 steps and added in a named value, like, I don't know, call it something like new card. Like I could have done it like this too. For clarification, I'll put it in place so you can see it. And I did this last time as well. I could see something like this. Card is of type new card. There's a new card is equal to a new card with a face passing in the suit, which we got, right? And then I can pass in here, instead of an anonymous object, I can pass in the new card. That's what it needs. Faces, or sorry, my list only takes cards. It's a list of cards, right? So this wouldn't be an anonymous list item anymore. It'd be a named list called new card. Same thing. But instead of doing it this way, I've elected to do it in one line, right? So that way, it's a little bit more streamlined. It's one line. Okay, so let's go back to the lab that you need to do, right? So for the lab, I'm asking you to do this. Using the example class, extend the list card object we defined. We did that. Check, right, if you follow my example. The deck class should include the methods that we constructed in the class. Create, display, and shuffle. Check. Number 2, done. Your driver platform should call the create. Well, it kind of does this. It does this through the constructor, right? And the display methods, and then the shuffle and display methods. Check. Number 4, finally, create a new method for the deck class named deal that removes the first card from the deck and displays it to the console. That's new. I could be mean and tell you to do it yourself, but I think it's better if we try and start it today and do it on your own later, right? Okay, I need a new public method called deal, right? So deck, deal the deck, deal a card off the deck, or pick a card would be another way to do it as well. Something to, and when I deal a card, when I deal one card or pick a card, or whatever you want to call it, the deal method is going to take the top card. What's the top card of my deck? Because imagine the deck of cards is a stack of cards, right? One on top of the other, right? The top card of my deck is which index? The 0th index, right? So I'm pulling off the 0th index. There's actually a method for that, right? So if I looked at the list methods, so if I go back here, here's my random stuff, right? I want to say C# list class, right? And if I pull the generic list type, again, we talked about this last time. Our list class has a bunch of methods, right? Here's all the methods of the list. Add, we did this one already. There's other ones here I'm not going to look at right now. Clear removes everything from the list, right? We actually did the opposite of that, which is create. We made our own, right? And create a deck. That's what we actually did, right? And there's one that removes, there's 2 remove functions, right? Or methods. One is remove, which removes whatever the type is, or remove at, which is removes the element at the specified index, which is what we want to use. So remove at is what we're going to do to pick the card off the top of the deck. Why am I removing the card? Because when I remove it, right, as soon as I remove that card off the top of the deck, right, what it actually does is it can never be pulled again. I've taken that card away from the deck. It's out. It's gone. So that card, that deck now only has 52 cards, or 51 when I pull the first card off. So it's gone. Now that when I use the remove at or remove methods, it actually gets stored somewhere. So if I actually look at this thing, let's take a look at the remove method. Remove at returns void and gives me the index, right? That's what it does. It says the 0-based index of the element to remove. That's what it does, right? It argument out of range exception. It could generate that if I pull the wrong card from the wrong place. It could do that. But what I really want to do is I want to store that value somehow, right? So when I remove that card, whatever that is, from that location, I want to store that value. I want to save that value somehow because I don't want it to just go away, right? So remove at, it says, the syntax is void, which means it doesn't return anything. That's bad. It means when I remove it, it's gone. And the value of the card is gone too. So when I make I'm going to go back for a second and look at the remove method for a second. If I go to remove, here's remove. Again, you can see that remove is different. It says bool, right? Type bool. And the type, it says if true, if the item is successfully removed, otherwise false. So you see, this is something weird, right? Like, I got to be careful. If I remove, which one does it remove, right? That's the other thing. Removes the first occurrence of a specific object from the list. So first from the list of type T, right? So type T would be the archetype card, right? So the first card object, right? So there's some stuff we have to think about. One is, do I want to make it remove or remove at? There's two different options for this. And they give you some really cool examples of how to add and then how to remove. What does it look like to remove stuff? Here's insert. That's another one we can do. We can insert an item. We can certainly remove at 3, right? All this does is takes the third index and takes it out. That's what it does, right? And it gives me examples of what my final list will look like, right? It also can search for an item, like item 1534, right? Oh, we don't have that 1534. Can I just do a remove, like just without anything at all? Is that possible? You gotta be very careful here because I might get myself in trouble. It might give me an out of range error, right? Let's try this out. So understanding the API is really, really important, is what I'm saying, right? And if we don't understand the way C# is going to handle the remove, right, or whatever method I'm using, because I'm actually borrowing somebody else's method, right? Then I might have kind of unspecified results. I don't know what my results are going to be. That's why I just read that. Okay, let's take a look. So I need to make a new deal method. Let's do that down here. It's going to be a public method, right? So we're going to say, let's define what it is first before I make the method. So what do I want this thing to? This method will remove the 0th item from the deck and return it. That's what I want it to do. Return it, right, to the caller, whatever calls this method. That means that my return value is going to be card. I want to return the card back to whoever called it. Why? Because now I have that value. I won't lose it. Okay, it's very important for me to do that because if I don't, then it's lost. I'll never see that. I can remove stuff out, but it's gone into the bit bucket in the sky. I don't want it. I want to be able to save that card and return it back to where I'm calling it from. Okay? What's the method going to be called? I'm writing a little backwards this time around. It's going to be called at method. It's going to be called deal. We can call this different things later on. And then, is it going to take any parameters? No. But the return type, at returns, is going to be of type card. It's going to return a card. That's what it's going to do, right? Let's write the method now. We just wrote the comments. Let's write the method. Public, it's going to return card, right? It's not going to be void anymore. And it's going to be called deal, right? Not going to take any parameters. And we need to return the card. So we're going to have to return some kind of card. We need to have the return statement in there. I'm just penciling it in for now, right? And what do I want to do? I want to take it the 0th element, the top element of the deck, and that's going to change because every time that I move things from the deck, the 0th element is going to be something else. So I got to do something like this. This, right? So we'll look at this as the element I'm looking at. So this 0, notice how it's giving me code hinting. The 0th element, right? I want to store this somewhere. This is what I'm going to return, this 0, right? I can't kill it and then return it, which means I got to store it temporarily. So card type, right? I'm thinking, right? Card type is return card. That's what it's going to be called, right? And I'm going to equal it, make it, assign it to this card, the 0th card in my stack, right? So this, the 0th card, so copy the 0th card in the stack, right, to the return card. I'm storing it temporarily because I'm going to return it down here, right? Why? Because I'm going to remove it. In order for me to remove it, I got to store it temporarily and then return it here. If I remove it right away in one line, I can't store it, right? Now I want to do a this dot remove at 0. Remove the 0th element from the deck, 0th card. When I say 0th, don't be afraid when I say 0th, what that means. It means the first one, because we use 0-based counting in arrays and lists. So 0th element is the actual first element. That's all this deal is. This deal method is just, that's just it. That's it. Let's test it to make sure it works, right? First of all, do you understand what the hell I just did? So if you don't understand this, then that's a problem, right? So card is what's being returned. Remember, it's like public static or public void. Card is I'm returning a card because my deck is a deck of cards, card type, right? So I'm returning one of the cards, right? And I'm temporarily creating a container that I can return later. I'm copying the current value of the 0th element of my list, and I'm plopping it into return card. And then I'm returning it here. But before I do that, before I return it, I'm going to remove it when I call this method. So every time I call the deal method, I'm actually going to be popping off the first card in the stack. It's the top stack, poof, that card's gone. And I can never get to it again. Why is that cool, right? If I deal a random number now, if I was to take a random number from the deck, if I took my deck of cards, let's say, and I took a random number out of the middle of the deck somewhere, right? It'd be the same thing, but instead of remove at 0, it'd be remove at whatever the card I chose, whatever the index is of the card I chose. And then I can never get that again. Why am I telling you this? Because in the future, you're going to do the exact same operation. You're going to remove this for your exam. I'm going to take you to get a random something from a list, and it's going to be at a random location, right? And you want to do that because then the values are unique. Actually, for assignment 2, this is the easiest way to remove a list of a power from a list of powers, right? I have a list of powers, 6 powers, and I'm grabbing a random power from the list, and it's popping out, and I'm never going to have the same list, the power from the list again, because that power is gone. It's been already assigned. Yeah. Correct. I'm using remove at because I want exactly the top card from my stack, right? Yeah. Correct. Is there something that I can do? Is there some problem with this? Yeah, there is. Remember we saw when I did the remove at back here before I end for the day. I want you to see that there's a problem with this if I do it this way. I'm just going to point it out to you. If I go back to remove at, this is back up online on the documentation, right? If I click remove at, it says, this is important to understand, it removes at, returns void, and we have a problem, right? Because if I remove something, here's a potential exception, which means it could throw an argument out of range exception if my index is less than 0. Or if my index is equal to or greater than count, which means if I have nothing left in the cards. If I try and deal the last card and I deal the next one, my deck is empty, there's nothing on the deck, right? Then I can't deal a card, can I? Which means it could cause an error, which means I should check to see before I try and do the deal if I have any cards left. I should check. If there's no cards left, can't do the deal, and I have to send back a message saying no more cards to deal, something like that. Yeah.
So I'm just kind of confused about this whole method. So you have your returning card, right?
This is just the name that I'm using, a temporary location.
Yeah, I'm saying in versus public card deal, you're returning object.
A card object, yeah.
Yeah. So then what you do is you have like the variable kind of thing where you're calling return card and you're saying that equals to 0 at the mix, right?
Yeah, because this is representing the list itself, which is this whole object.
Save that. And
All I'm saving it here, because if I was to do this first,
it's like you're burning it if you don't do that.
yeah, if I do this first, it's gone. So then I don't have this value anymore. So I got to save it first, kill it, and then return it.
Okay, so you would actually, the whole thing would be kind of displaying this dot remove 0. That's what the display part of it would be going.
I would lose that card. It would be gone out of the list. It's gone, right? Like I actually take it and destroy the card. I go, that 0th card is gone. And then my whole stack shifts up 1. So my whole stack is 52 cards, right? I take the top card off, the 0th card. Now there's only 51 cards. And my 0th card is the 2nd card, or the first. It's called, can be called the 1st card, right? And if I pop the 1st card off, now it's the 2nd card. And if I pop the 2nd card off, now it's the 3rd card. And it keeps on shifting up, shifting up, shifting up as I keep on dealing cards off the top of the deck, right?
But in memory would come back because
I'm holding it here and I'm returning it. Now, here's how I'm going to use it. So in here, I'm going to say if, this dot count, right, is greater than 0. It has to be greater than 0. And do this, right? Otherwise, if I did that, then I would potentially have a out of range error because there wouldn't be anything to take off, right? I can't do this func method unless I have greater than 0 cards in my stack, in my deck. So check to see if the deck is not empty. If I have an empty deck, like I do in the beginning, when I create my object here, if I didn't do my constructor creates the deck, it adds cards to it. If I didn't call my constructor, my deck would be empty because it creates an empty container of list card type, right? That's all it does. But my create method loads the cards into the list. It loads it up. It creates the stack, right? Now, when I'm dealing the card, I take cards off the stack, and there's going to become a time and place where there's no more cards left. And if there's no more cards, that's bad, right? That means that I'll have an error. It'll crash my program because there won't be any cards to take off the stack because the stack doesn't exist. Let's test this out to see if it works, right? And how do I test this out? This is part, almost the entire lab here. Actually, it would say it's 99% of your lab right here, right? Okay, so I've got my main method, I've displayed, I've shuffled, now I'm going to deal. So I'll say deck.deal, right? Well, guess what? It returns something. This thing returns a card. So I can say something like this. What card did I return, right? Well, I'm going to do a console write line, right? So I'll say a console.writeLine, then I'll do the card deal, right? So I'll say do one of these. So console write line, and I'll take this deck deal, which returns a card. I'm going to output what card it returns, right? Now, can I do this? No, because my card is a card type, right? I can't do this. I have to do it in 2 lines. Let's try this out. So let's make a new card. We'll say card returned. We'll say card, and we'll say card dealt. Card dealt, right, is equal to deck.deal. So card dealt is going to be the card that I dealt from the deck, the random card that I got from the top of the deck, whatever that card is. And over here, what I'm going to say is card dealt is what? The 0 of 1, which means the card dealt dot face, comma, card dealt dot suit, right? I'm saying, hey, get the card dealt from the deal method of the deck. So deal a card from the deck, right? Hold it in the card dealt object, and then show it to me on the command line, right? And then let's add another space, and we'll just do it just to prove that it's happened. Let's do another deck display. Right? And let's see what we got. If you guys understand all this, you're golden. I expect to have questions later on. All right, so this is their initial deck. You can see that it's 1 of hearts and blah, blah, blah. This is the initial state of the deck. Then we come down here. We randomize the deck, which means I should get the 3 of spades. That's the top card of the deck, right? This is in order. So I go down here, and then I can say, card dealt, 3 of spades. That's the one I got. Now look at the deck. There's no more 3 of spades. It's 6 of diamonds at the top, which, if you look, was the second card, 6 of diamonds. So now I've dealt my card, and it's out of my deck. Total card count, 51. There is no more cards. There's no 52 cards anymore, right? Because my deck of cards is low. And I can check that. I can go deck.count, and it'll count how many cards are inside the deck. Okay? Why am I showing you this simulation? Because, you know, there's reasons always why I do stuff with you guys, right? Always underlying reasons. Because, like I said, by next week, I want to build a little game where I do this. I have 2 players. Player 1 with a deck of cards, player 2 with a deck of cards. Now, on the first turn, they both deal a card, and they compare the faces. Is a 1, if I deal a 1 and you deal a 5, play war, then you win, right? 5 beats 1. So now, huh? Like blackjack, but almost like war. You ever play war? War is like when I have a deck of cards, you have a deck of cards, and I deal my first card, as an example, right? And I deal, let's say, a random number like 5, and you deal 1. Well, 5 beats a 1. 5 is greater than 1, so therefore I take your card and include it at the bottom of my deck. My 5 and my 1, my 5 and your 1 go at the bottom of my deck. Now I have two 1s, right? Because I have my 1 and your 1. It's inside my deck. Now I have a duplicate of what I have, right? Now we play again, and I deal my card. You deal a 3, and I deal a 3. Oh, they're the same, so they don't take each other. Therefore, now it's war. And the game of war goes, if I have whatever the face value is, if it's 3, as an example, I got to put 3 more cards back. 1, 2, 3. And now, as an example, I have, let's say I randomly draw a 9 and you have a 10. You take it. So you take all my cards that I just drew and you put them inside your deck. And they keep going back and forth, shifting cards between two decks until there's only one deck. Whoever wins has all the cards. The other person has 0 cards. Game of war. Very, very simple game. Silly game. We played as kids. But we can make it so that 2 computers can fight each other, or 2 computer players can fight each other, and it can happen in 2 seconds, because that's how fast the computers are, right? Done. Who won? Computer B. And here's all the cards. And by the way, it'll show you each turn, each round. Here's what happened, right? Questions around this? I know it's tough. Guys, this is not easy stuff. Just putting it out there for you. But we need to understand how to compose classes like we've done. And this is the exercise. So complete your lab, but don't just copy what I did here. I want you to understand the process. I did the Fisher-Yates shuffle with the shuffle. When the deck, especially on the deal, with this deal method, not only am I removing a card, but I'm checking to see if there's any cards left. And I'm also copying the card in a temporary location that I'm returning so I can use that card's value later on. Okay, guys, thank you so much. I'll see you on Wednesday, right? And we'll continue with inheritance and start polymorphism. Thank you.